Hi guys, this is our first lesson of the third unit. It's called Transformations of Functions, that's the unit. And today we're going to look at some of the functions that we're going to graph throughout this unit and a bit even into some other units. So there is going to be a lot of graphing, and for that reason it will take a little bit of time, but you will get the hang of it and you'll get to learn these certain functions. So today we're going to look at these base functions, we call them, or the parent functions. So the base functions are, some of them you've seen. So instead of y equals x, I've written f at x equals x, but same thing as y equals x. So you've seen that before, that's a straight line. Then our parabola or quadratic, we've got x squared. Then I mentioned the root of x, which is called the radical function, and we'll write that down in a minute. And then there's this reciprocal function, which is 1 over x. And so you're going to get to know all of these and be able to do a bunch of things with them as we go through the unit. It's not all going to be graphing, but there's definitely going to be some components in the beginning to do that. So what I'd like you to do is these next 2 pages, I think that you can do on your own. And so I'll get you started, but for example, it's got this base function, and we're going to start with the quadratic. We're going to kind of jump over the straight line because everyone's seen it so many times. But for our quadratic function, I've given a table of values here, and it goes from -2 to +2, and we sub these in for x. So for example, this would be -2, and because it's x squared, I square it. So this becomes 4. I do the same thing for all of these, and I get the corresponding y values, or what the function is equal to at those x's. So if you go through that process, and you can fill this in, and then you can plot those points. So you've probably done this many times for this graph. And we label it, I'll call it f at x because that's what we wrote there, equals x squared. And so that's our base function for the quadratic. And what I would call these are my 5 key points. And ultimately, you're going to want to know these points. But if you just remember, it goes from -2 to +2 for x, and you sub those in, you can always come up with the points yourself. So those are our key points that we're going to work with for that function. So one of the things we're going to do with all of these functions, and we're going to just stick to the quadratic for the moment, is we're going to see what happens when you transform them, or move, basically means move the graph around. And so we're going to compare here, and you can try this yourself. We're going to compare the base function, so x squared, to what happens when I put -2 in brackets with it, with the squared outside, and then also +2 in brackets. And so to help you along, I've given you a table of values here. So I'm going to plot the base function first. So the one we just did above, just for a comparison. Like that. And so now we're going to take the next one. So I'm just going to change colors. And I'm going to plug these numbers in. And so at this point, I think you can pause the video and you can just try these and see what you get. And so if I plug these in, so you can pause right now. So I got -4 plus 2 gives me -2, and then I square that, that becomes 4. -3 plus 2 becomes -1. -1 squared becomes +1. -2 plus 2 gives me 0, and then I square that, that's just 0. And then similarly on the other side, I get these values. And so if I plot these, so -4 and 4, and so on. So I've got the same graph, only you'll notice it's moved to the left. And so this is actually the graph of y equals bracket x plus 2 squared. So even though it was +2, it moved to the left 2 in the negative direction. So let's see what happens here when I put -2 in. So notice I've adjusted the x values. So if I plug these in, and I'll let you try this. So this one's going to be 4, and you might guess at this. And all of them work out to be the same y value. So if I plot those, so this is my x minus 2 bracket squared. So even though in the bracket it was minus 2, it actually moved to the right 2. So you'll notice if you look at the original x values here, so if I go back to these guys, these are my original x values. What I had to do when I added 2, it actually moved the graph left, and I subtracted 2 from all of my x values, and I ended up with the same y values corresponding. Similarly, if I minus 2, I actually added 2 to here to compensate for the minus 2, and I get the same y values. So it has this opposite effect when you have it in brackets. We're going to talk about that in a bit. So at this point, I think you should be able to get the hang of it. I'd like you to try the next ones on your own. So again, I would press pause, come up with these, and continue on until you get to the next page. So I'll go through this stuff in a second. You can go through that one, and then I'm going to go through this together with you, the last 1 over x. So pause it and go through these next couple examples and see how you do. So for this one, this is what's called the radical function. So our radical function, which has got the radical in it, and that's why it's called the radical function. So it's the square root of x. And it forms this thing like here. Notice I put 1 point here, -1, but if I take the square root of a negative, it just doesn't work. I get an error. So it doesn't exist below 0 because anything negative won't work. And so I plug these in, the square root of 0, 0, square root of 1, 1, square root of 4. So again, these are my key points for the radical function. And they're all, notice, perfect squares, except for 0. And so I picked those numbers because they work well, because I square root them and I get whole numbers for my y. And so it looks like this. It's kind of like half of a parabola turned on its side. And we'll see that relationship later on. Okay, so if you continue on, when we look at this radical function and we're moving the function around, so this time I put brackets here. I'll just re-put them. But I've got, it's like I have under the root this operation where I do this underneath the root first, and then I take the square root. So remember, like y equals x plus 2 bracket squared. If you don't remember, just go back a page. This shifted it or moved it left, even though it was plus 2, it moved it left 2. What happens is very similar with the radical function. So if you look at the base function here that goes like this, the green one is the one, so this one here, I've moved it 2 to the left, but I do the same thing. I put plus 2 under the root this time, and it moves to the left. And you can see similarly, when I have minus 2, it actually moves it to the right 2, like that. And so this type of thing is called a translation. We're shifting it left to right. It's all the same stuff, shifting, translation, transformation. And that's what this is here down at the bottom. So a translation is just a transformation that results in a shift without changing its shape. And all of these are horizontal translations. So the next part is to look at what happens with vertical translations, where we're shifting up and down. So you can try this if you haven't already, or you can press pause and go through this. So this time, we've taken the parabola again, so y equals x squared. And you'll notice here, I've adjusted so I still have the same x values, but now I've got a y value I'm adding 3 to. So all of these numbers, 4, 1, 0, 1, 4, it's like I added 3 to all of them. And I got this by just plugging in the x values, but at the same time, I could have just added 3 to all of those original y values. So this red one here is the vertical translation up 3. So unlike the horizontal translation, the vertical translation is directly whatever the number is. So if it says plus 3, it's moving up 3. And if it says minus 3, like this one, it's gone down 3 from its original key points that we had of x squared. And similarly, if I took these original y values and subtracted 3 from them all, I would get the new y values here. And so it's a lot to take in at the beginning, but we'll get through it and we'll talk about it as we go through. Okay, so the next one is the trickiest one, at least at the beginning, and then eventually it becomes really easy. So this is what's called the reciprocal function. And it's the reciprocal because it's like I took x and I flipped it so it becomes 1 over x. And so it looks like this. So I've given some numbers here that we're going to plug in, and see what happens. So the first one, if I take 1 divided by 0, and you can try this, it doesn't work. It's an error. And so this function does not exist when x is 0. And if I plug in 1, 1 divided by 1 is 1. And then if I take 1 divided by 10, I get 0.1. 1 divided by 1,000, I get an even smaller number. 2 zeros and the 1 after the decimal. Then if I plug in 0.1, it's going to get larger, so this becomes 10. And then 0.001, I divide, that gives me 1,000. Plug in -1, I get -1. -10, I get -0.1. And then here, -10. So there's a lot of points there, but it gives you an idea what's going to happen. So let's first start with these two key points, 1 and 1 and -1, -1. So if I plot those, that's here and here. Knowing again that the function does not exist when x is 0. So it's never going to hit that value. The other part that you may want to include, and you don't have to because it's really hard to graph, but if I go to 0.1 for x and go up to 10, it's like right there. And similarly, if I go to 10, it's 0.1 for y. So it's like that. Even on this negative side, it's like this. And this is where I said, also use your graphing calculator to help. So be sure to check this on your TI. So what I do is, there's this curve, and it's hard to graph, but it goes like this, and it never hits that axis. And similarly, it goes like this, and never hits that axis. And then on the other side, and when we were doing domain and range questions, you saw this kind of thing, and it goes like that. This is my y equals 1 over x. And what happens is, we talked about this before, but what happens is I've got an asymptote horizontally at 0 and also vertically like this. And so these guys, remember, are asymptotes. And so both of them, one is horizontal and one is vertical. And the equation of these asymptotes, I can give them equations if I want. This would be the equation of x is equal to 0. And this would be the equation of y equals 0. And so in this one, there's actually only 4 key things to know. The 2 highlighted things, I'm going to get rid of this highlight. So the 2 highlighted things there, and also these 2 asymptotes, which is x equals 0 and y equals 0. But as I said, this is going to take a little while to get used to. So if I was to think of the key points here, my key points are 1, 1, -1, -1, and also these asymptotes. So these are my key values. They're not always points, but they're key values to learn. The other ones, as long as we know the general shape, how it goes towards the asymptotes, you don't really need all of those little points to finish it off. Again, we'll work with that, but that's basically the base function for the reciprocal. Okay, so in summary, this is going to look weird, but I can put this in general function notation. And so if I had some original function f at x, right? And even, it doesn't matter what you call it. Let's say f at x is x squared. I can change that function by putting a number in the bracket of that function and calling it d. So d is going to shift left/right. And I'm just going to put in the opposite direction. So if it's negative, it goes positive. If it's positive, it goes negative. And then the other one is the number that's outside of the function, which is a shifts up or down. And that one's direct. So like you can have any of these graphs in general. Let's say it is this one, and I'm shifting it 2 to the right and, I don't know, 4 up. That's what that graph would look like. If the function, let's say it's g at x equals the root of x, the equation would look like this. X minus 2 would shift, oops, don't use that. And my x minus 2, I'm just going to get rid of that bracket. You don't really need the bracket, but you can put it in. So I've got the root of minus x minus 2 and then also plus 4 like that. And so you can apply these into different functions, and we'll practice that as we go through. So one question you could have that doesn't involve any graphing, but it involves knowing what these things do. It says, given some function, we don't care what the function is, describe in words the following transformations. So if I take the function and I add 3 outside, is this a D value or a C value? So if you go back up to this here, is it D or C? And hopefully you get that the answer is that it's C. So what happens here is this is a shift up 3 units. And the next one, we're taking h at x and we're just transforming f at x, but this time we've got a negative 4 inside. So this is where my d equals negative 4. And remember, this is going to shift in the opposite direction, so this shifts right 4 units. And then the next one is just a combination of both. So D is 3 inside, and C is negative 5. So we've got a shift in the opposite direction, so it's going to go left 3 units. And this is a shift down 5 units. That. So one way to do this, and it's the recommended way, is to transform the key points of your graph. So if I look at this one, it says sketch this. And I want to do it using the key points, and I'm going to transform them. So the first thing is to recognize that the base function, the parent function if you want to call it, is based on what we see there. So it's the y equals x squared. So if I take the key points for y equals x squared. So the key points here are 0. Oops, I'll start with negative 2. So negative 2, and this, you could go back up to the beginning and find these key points. And you're going to need to write them down or have them close by. So that's these points here, negative 2, 4, negative 1, 1, and so on. So I've got negative 2, comma 4, negative 1, comma 1, 0, 0, 1, 1, and 2, 4. Again, these are my key points for this function, the parabola. So what I'm going to do is, based on this equation, I'm going to transform them. So the plus 3 tells me that this is shifting left 3 units, and the minus 4 says it's going down 4 units. So as an operation, it's going to have x, I'm actually going to minus 3 from the x's. And the y values, I'm going to minus 4. So I'm going to take all of my key points on the left side, the left column, and I'm going to do this to them. And so I've got these little operations that I'm going to do. So I'm going to write it in as the answer, but basically I'm going to take negative 2 minus 3. So negative 2 minus 3 gives me minus 5. And I'm going to take 4 minus 4, which gives me 0. That is my new transformed point. And the reason we do this is because it's going to give me the overall shape of the graph. Whereas if I just created a random set of x values to sub in, I won't necessarily get everything, including the vertex. So I'll do the same thing for all of these points. So -1, I'm going to minus 3. So that becomes -4. And then 1 subtract 4 becomes -3. 0, 0 just becomes -3, comma, -4. 1, 1, so I take 1 minus 3, gives me -2. Then when 1 minus 4 becomes -3. And continue on, and you can try this yourself. That will be -1, comma, 0. So I'm going to graph the original just to have a comparison. So my base function, so that's x squared. And then I'm going to graph this new one. So we take these points, so -5, 0. The nice part of this, if you do make one mistake, it's generally quite obvious, because you'll notice one point just doesn't fit in. And so notice I have these 5 points. I've got the vertex and all the points near to the vertex, which allows me to have this. So this is the function f at x, and I'm going to write it full equation in just so you have it. So that's that guy. So this method of transforming, it looks like this. I take the d value and I add or subtract it depending on what it's supposed to do. And then similarly with the y value, I add and subtract the c value. Okay, let's continue on and try this with the harder one. So this one, I'm going to take my reciprocal function, the key points. So in this one, I've got y equals 1 over x. And this one is what I'm going to do to those points. So let's first start with the key points. So the key points for 1 over x are 1, comma 1, -1, comma -1. And then I have these asymptotes, x equals 0 and y equals 0. And really, that's all you need. So let's start. We'll just plot those ones. So we have this thing where it goes close to the asymptote but never touches, and you don't need to graph a whole lot of it. So what I'm going to do is now, based on this, I have to decide what's happening. So this is like being in the brackets when I put it down below. So this becomes my d value. So d equals -1. So based on that, that's a shift right 1. And the +2 is my c, which tells me it's going up 2 units, like that. So I'm going to take these x values, my original points over here, so these guys and this, and I'm going to transform them based on what these values are. So if I have 1 over x minus 1, it's like I'm shifting right 1, so I add 1 to the key points. And the y values, I'm going to add the c, which is +2. So if I take the point 1, 1, I add 1 to the x, so that becomes 2, and I add 2 to the y, so it becomes 3. Similarly, I do the same here, so -1 plus 1 becomes 0, -1 plus 2 becomes 1. And so we can plot these points if we want already. So I've got 2, comma 3, so that's up here. So it's shifted, remember, right 1 and up 2. And then I also have 0, 1. So 0 for x and 1 for y. The other part I need here is that I'm going to do the same thing for my asymptotes. So I add 1 to 0 for that, and I add 2 to the y like this. So let's put these into my graph. So I'm going to show them as dotted lines. So x equals 1 is this vertical line here, like that. And then y equals 2 is the horizontal line going across here. So this is x equals 1, and this is y equals 2. So what I'm going to do with my new graph, and I'm actually going to delete the old one just so it doesn't look so busy. I'm going to connect these points so that they go close. So I'm actually not connecting the points to each other, but they're going close to the asymptotes, but never touching. And it's always going to work like that. So you've always got that kind of shape looking at, similar to what we had with the original 1 over x. So this is the graph h at x equals 1 over x minus 1, and then I add 2 on the outside, like that. Okay, so last one here, I think. Oh, there's a you try, but you can try that yourself. Last one here we'll do together is I've given you this random shape, and I'm going to tell you to do these things to it. And so we're going to take the original function f at x, and I'm going to change it to make it a new function g at x. And what I'm going to do is I'm going to shift. So remember, this is shifting right 2, and this is going to shift down 3. So I'm going to take each of these points, and if you want, you can write these points out. It's up to you. But the operation that I'm doing to them is x plus 2 and then y minus 3. So some people like to write them out like this. So I'll do a couple. A is negative 5, comma 0. B is negative 4, 3, I guess. And I'll do C as well. So that's negative 3, comma 3. And what we're going to do is transform them like this. So I'm going to add 2 to the x, so this becomes negative 3. And I'm going to subtract 3 from the y, so that's negative 3. Similarly here, I'm going to add 2, so this becomes negative 2. And then subtract 3, so that's 0. And next one again, add 2, so that's negative 1. And then subtract 3, that's 0. Another way to do it is to just literally go from A, and I know I'm going to go right 2, and then down 3. So that puts me right there. So negative 3, negative 3. Go with B, right 2, down 3, like that. C, right 2, down 3, and so on. So if I try D here, I'm going 2 to the right, 1, 2, 3 down, like that. Same with E, 1, 2, 1, 2, 3. F, 1, 2, 1, 2, 3. And then I just connect them in the same way that I found them originally. So all of these are connected with straight lines, like that. So this is my new function, g at x, which is the transformed function of the original, which was this blue guy, which is f at x. So really, you can do this to any graph, and it's all rather whether or not you have the value inside the bracket versus outside the bracket, or inside the function versus outside the function. So learning that is going to be key, and you'll see next class we're going to expand even further because we're going to flip things upside down, and we're also going to multiply, so we stretch them out. Okay, I will complete the you try, and so I'll go through the you try with you if you want. So when you look at these, it says state the transformations taking place in sketch function. So before that, I'm actually going to state what the base function is, because we need to know that. That's key. So hopefully you recognize that there's a squared here, so my base function is y equals x squared. And so what's happening to y equals x squared is that it's shifting left 3, and I'm going down 2. So if I start with my base function, y equals x squared, and I start with those key points, so these are the things you're going to really learn and know. So I got negative 4, or negative 2, 4 rather, and so on. Oops. Jumping ahead. And so those are my key points. What I'm going to do is transform them based on what I wrote there. So I'm going to go left 2. So that means x, or left 3 rather, x minus 3, and then y down 2. So y minus 2. So I'm going to take those key points, and I'll just write a new table of values where I take each of those x's. So why don't we just start with the x's? So at minus 3 from each of them. So negative 2 becomes negative 5, negative 1 becomes negative 4, 0 becomes negative 3, and so on, like that. And then the y values, I'm going to subtract 2, like that. So now I have the key points that I can graph. So if you want, you can start at the vertex. You don't have to, though. Like that. And that gives me the transformed function. So this is my new one, and I'm just going to label it f of x. So this time, my base function, if I look at number 2, again, hopefully it becomes obvious, is y equals the root of x. And what's happening to it is this is outside of the root. And so because it's outside the root, this is the c value, which shifts it up or down. In this case, it's shifting down 3. So the key points for y equals the root of x so if I start with those, so a table of values, I've got 0. Remember, this is the one where we take the perfect squares. So it only has it only has 4 points that you need, and I square root them like that. So those are my key values to work with. And what I want to do is just keep the x value. Notice I didn't put the y in. Keep the x value, but the y value I have to change by subtracting 3. So all those x's don't change, but the corresponding y's I'm going to subtract 3. Like that. So now I've got my new points. So I take the original and it's going down. You'll notice one of the points doesn't fit onto the scale, and that's okay. So this is my g at x, which is, and I'll just write it out, root x, and then minus 3 outside of the root. Like that. Okay, moving on. The next one, or next two, could be a bit tricky, but remember the key points again, for this is my base function, which is 1 over x, the reciprocal one. And so it's shifting, if it's down here, it's like being in the brackets, so this shifts left 3 and down 1. So if I take my key values for 1 over x, so -1 goes with -1, 1 goes with 1, and then I have x equals 0 as my asymptote and y equals 0. So I'm going to take those guys, and I'm going to, if we're shifting left 3, so it's x minus 3, and then the y value is y minus 1 because I'm going down 1. So this becomes -4, -2, and then 1, 1 becomes -2, comma 0. And then the x value, I just take -3 off of the 0, so it becomes x equals -3 for that asymptote, and the y, I'm subtracting 1, so it's -1. So it doesn't matter which points you start with. Let's go with just these values, and then we'll do the asymptotes in a second. So I got -2, comma 0. And then my asymptotes, I'm going to do it in a different color. So x equals -3 is this vertical line, and y equals -1 is this guy. So this gives us my boundary as to where my graph is going to go. So it's going to come close to that, infinitely close but never touch. And similarly here, like that. So this is h at x. So you can see these ones actually become pretty easy after you do it a little bit. So again, base function here is 1 over x. This time we're shifting right 1 and up 2. So I'll start with these key values that we just wrote down beside us here on the previous question. So I got -1, -1, 1, 1, x equals 0, y equals 0. So we're going right 1, so that's x plus 1. Oops. And the y value is going up 2, so x plus 2. So take these points, this becomes 0, plus 2 to my y becomes 1, and 2, comma 3. And then I add 1 to my asymptote, and I add 2 to this asymptote, so we get these. So if we graph that, I've got 0, 1, so So that's there, and then 2, 3. And then my asymptotes is x equals 1, and then y equals 2. Like that. And we connect them. So this is j at x, because we're running out of letters. Okay. Hopefully that's okay. It's a lot to take in at the beginning, but really this unit, we're going to repeat a lot of things, so you can try these homework questions.